All right, last page. Okay, a triangle has side lengths 10, 11, and an area of 50. Determine the two possible measures of the included angle. Okay, so I'm just going to draw a triangle here. Okay, this is 10, this is 11. We want to find the included angle. I'm going to call it theta, which is like a O with the line through it. And we know that the area is 50 centimeters squared. So let's write our formula. Area equals 1/2 the two sides, which is 10 times 11, and then sine of our angle, theta. And so you know the area is 50, so I'm going to put that in there. 50 equals, and 1/2 of 10 is 5, and 5 times 11 is 55. Sine of theta. And then I divide both sides by 55, and I get sine of theta equals 50 divided by 55. And then now to figure out my angle, I have to do an inverse sine function. And in order to do inverse sine, I have to hit the second button and sine, and that's going to give me the inverse sine, and on your calculator it looks like this, sine with the little -1 exponent here. And that's going to help me go from this ratio of 50 over 55, and that's going to help us figure out the angle. So let me show you on my calculator here. So I'm going to hit second and sine, second, and then I hit sine, and then I get this little thing here, and then I'm going to do 50 divided by 55, and then hit enter, and it's going to tell me that my angle is equal to 65.38. Okay, now on the previous page we just said that because this height is going to be the same regardless if it's an acute triangle or if it's an obtuse triangle. So let's pretend that this side swung out this way. Then I would have this being 10 and this being 11. And if these heights are the same, right? If the red line is the same as this red line here, because you know area of a triangle equals 1/2 base times height, right? Well, if the height is that red line, right, and the base is 11 here and 11 here, these two triangles are going to have the same area. Now, how do I figure out the area? So I can use 180 minus this angle, and I'm going to get the other angle is 114.6. So whether I use the acute angle of 65.38 or the obtuse angle of 114.6, these two triangles will have the same area because they have the same base and they have the same height. Okay, so same sort of thing for these next problems. This is 5, this is 8, this is my angle. And I'm just going to put up my answers for these and explain it. And then we'll do example 16 together. You might want to hit pause if you want to copy this down. Okay, so the lengths of 5, 8, and we've got the area, so we're trying to figure out the angle. So 5, 8, and you've got the area is 15. Okay, so 1/2 of 5 times 8, well 5 times 8 is 40, half of that is 20. Divide both sides by 20, I get sine of the angle is 15 over 20. Okay, 15 over 20 gives me 0.75. So then I'm going to hit second sine 0.75, and then I'm going to get my angle. And then to figure out the other angle, in case it's obtuse, then I can do 180 minus this value, and that's going to give me my other angle. Okay, same thing here. You've got 45 and 53. We want to find this angle. You know the area is 800. So I've got my two sides here. I've got my area. And then I do second sine of this value and get my angle. And then 180 minus that value, and you get the other angle. Okay. You might want to hit pause if you need to copy this part down. Okay, so let's do the last one together. Okay, so the area shaded here is going to be the area of the sector of a circle minus the area of the triangle. So let's think about this together. So the area of the sector of a circle is this part right here. It's like a wedge of a piece of pizza, right? And so this area, and we know this distance here is 4, right? And so the area of a sector is equal to the angle over 360 times pi r squared, right? Because the area of a circle is pi r squared, right? So we know the radius is 4, so, and we know this angle here is 72, so I'm going to say, 75, so 75 over 360 is going to give me the ratio of this wedge here times pi r squared, so 4 squared, minus, and the area of the triangle. So the area of the triangle, you need to remember that we've got our two sides, which are 4 and 4. Right, that's 4 and 4, and you know this is 75. So to figure out the area of the triangle, I use 1/2 4 times 4 and sine of 75. And if I put both of these into the calculator, for here I'm going to end up with 10.47 centimeters squared. And for this I'm going to end up with 7.73 centimeters squared. And then I subtract those two, and I get 2.74 centimeters squared. And that is the area shaded. You may want to hit pause and replay parts if you need extra time to understand this.